Hello everyone, welcome to Explore Hub. Use the comparison test to figure out whether the series converges or diverges. The series we've been given goes from n is equals to 1 to infinity and is 3 over n to the power of 4 plus 5. Now, let's try doing this using the direct comparison test. So to do that, we have a series and we need to compare that to some other series. So we always look at the highest power of the series. And so we have, let's say, n4 plus 5. This is our current series. But now we can write this, we can see what the highest power is, which is 1 over n to the power of 4. So we can call this p of n, and this can be our a of n. Now we can compare both of these series. So we know that whenever we have a series which is 1 over n to the power of p, anything, and if this number, the power, is greater than 1, that means that our series always converges. So therefore, our Bn converges. And we can see that for all values of n greater than or equal to 1, our series 3 over n to the power 4 plus 5 is, actually we can factor this out. We can take 3 out for now. Let's say our an is equals to 3 series 1 over n4 plus 5. So let's take this right now. So let's say 1 over n4 plus 5 is less than or equal to 1 over n4. And if this holds true, which it does, you can clearly see that 1 over n4 plus 5 will always be smaller or equal to than 1 over n to the power of 4. For example, let's substitute 1 instead of n. So we get 1 over 1 plus 5. And the other one we get is 1 over 1. So 1 over 6 is less than or equal to 1, which is true. So therefore, as we learned in our lesson, if Bn converges, then An will also converge. Let me write that neatly. If B of n converges, then A of n will also converge. And thank you for joining us. I hope to see you in the next lesson.